Rapid setting hydraulic cement is being studied to determine if it can be used as a solution for structures in Texas. This is very important in components related to bridges and decks. Researchers from the Texas Department of Transportation and Texas State University performed tests on various rapid cements, identifying its durability and performance to develop guidelines for implementation on decks and bridge structures.
So there are some specialty cements called rapid setting cements that gain strength within hours. So we're talking 3,000 PSI in 3 hours. So imagine if you pour a column and you're waiting 7 days to do something versus I pour it today, tomorrow I could strip forms and start a new process, right? So the idea was how can we utilize these specialty cements in more of the cast in place operations and then bring in the precast bridge elements to kind of speed up the entire project as well.
So we did both lab and field work. And by field work, mostly what I mean by field work, we essentially did a lot of concrete samples that we exposed to sort of real world conditions, not necessarily actual bridge structures or going to actual job sites, but we essentially exposed them outside in the San Marcos, Texas environment. We did a lot of tests in terms of performance, specifically for durability, and a lot of durability tests that are available today that are standardized are really intended for the traditional Portland cement binder system.
Some of the durability concerns were an issue. And so through this project, we learned that, yes, that is a concern. And so we need to be careful of where we use these in certain applications. And so I think the durability, it's still new to us. And so we need to continue learning. And so this project really highlighted those aspects of what we need to continue to research.
The biggest benefit from this research to the driving public specifically is that, I think we've been able to really give TxDOT sort of another tool in their toolbox, right? So, while we still need, I think, more information, more data to really sort of be confident about where these materials can be used, there's definitely viable applications for them. And being that they have, these unique capabilities and unique characteristics, so they have the ability to sort of generate strength much more quicker, essentially turn around the construction over much faster, and the driver, obviously, they're very happy about when they can turn around construction projects much faster.
Our next step is to do some more long-term monitoring of those durability specimens that were fabricated during the research project. So they made concrete, they'll set them in certain environments, and then we'll monitor them and continue that work. So we want to get, again, try to extrapolate some longer durability, longer time period out of this information or out of those samples, so that way we can make better decisions of, well, maybe these aren't good for a marine environment or an area where de-icing salts will be used, but maybe Central Texas or something down in the valley where we're not a very aggressive environment, maybe those would be the regions we would use these, but some of these other locations, we probably won't go there. So learning those durability performances of these materials would help us make those decisions. So I don't think we're quite yet on the implementation. We still have a little bit more knowledge to gain on some of those durability aspects.
For more information and to find the publication for this project, please visit the TxDOT Research Library at the link shown below.